Hello everyone. In this video, we will discuss about number of hybrid orbitals and pure orbitals, and also we will discuss ratio of hybrid orbitals and pure orbitals, guys. Already we know that I started organic chemistry series. In that series, it is one of the video, guys. Just follow my videos and learn organic chemistry, guys. Before going to the topic, first we should know how to find hybridization of carbon in organic compound. For example, if you take a carbon with all four single bonds, then the hybridization of the carbon is simply sp3 hybridization, guys. If you take carbon with one side double bond, either side, this side or this side, one side double bond, then hybridization of that carbon is sp2 hybridization. If carbon with triple bond, then the hybridization is sp. If carbon with both side double bond, also hybridization is sp. First of all, you should remember this one. If carbon with four single bonds, then that is sp3 hybridization. If carbon with double bond, then that is sp2 hybridization. If carbon with triple bond, that is sp hybridization. If carbon with both side double bond, then that is also sp hybridization, guys. Now move to few examples for this topic. If you take this molecule, so here 1, 2, 3, 4 carbons are there. If you observe that first carbon, it is paired with a double bond, so the hybridization is sp2. Here if you observe that second carbon, it bear with also a double bond, so this is also sp2 hybridization. If you observe third carbon, this one is also with a double bond, so this one is also sp2 hybridization. Now here final carbon also bear with a double bond, that's why it is also sp2 hybridization, guys. Now another example have to take. If you take like this example, CH triple bond, C bond, C bond, CH3 double bond, CH2. Here the first carbon is linked with a triple bond, so this carbon hybridization is sp. Second carbon is also linked with a triple bond, so that's why it is also sp. Now if you observe this carbon, here one side of this carbon is double bond is there, so hybridization is sp2. If you observe this carbon, this one bear with a single bond and 3 hydrogen, all are only single bonds, so this hybridization is sp3. Now move to final carbon, there is a double bond here, so means the hybridization is sp2, guys. Now I have to take another example. Now if you see this example, here first carbon only single bonds are there, means sp3. Second bond also single bonds are there, second carbon at, so sp3. But if you see the third carbon, there is a double bond so means sp2 hybridization is there. The next carbon also with a double bond so it is also sp2. Next carbon if you observe, they all are only single bonds, means it is sp3. Next carbon only single bonds, sp3. Next carbon also only with single bonds, sp3. If you observe next carbon, there is a double bond so means sp2. If you observe next carbon, that is also double bond sp2. Next carbon only single bonds are there, means sp3. Now final carbon also with single bond only, means sp3 hybridization is present in that molecule. For example, if you take a molecule like this, so here if you observe this CH3 group, it bear with only single bond, means it is sp3 hybridization. Now move to benzene ring. Here 1, 2, 3, 4, 5, 6 carbons are there. Each and every carbon connected through that double bond, so all are involved in only sp2 hybridization, guys. Now if you see this carbon, triple bond is there, sp hybridization, triple bond is there, sp hybridization. Now there is a double bond means here it is sp2 hybridization. This one is also sp2 hybridization. Now I have to move another example. If you take like this example, CH2 double bond, C double bond, CH2 have to take. Now if you observe this example, if you observe this carbon, one side of this carbon is double bond, means sp2. If you observe carefully this middle carbon, both side of this carbon is two double bonds are there, means sp hybridization is there. For this carbon double bond is there, means sp2 hybridization is there, guys. I think you understand how to find hybridization of carbon in organic molecule. So now I want to move to next topic in this video, calculation of number of hybrid orbitals. I will provide shortcut at the end of this video, but first you should understand exact concept, guys. So next topic is finding number of hybrid orbitals, guys. So look here, for example, if you take molecule like this, CH3 bond CH3, only single bonds are there now, means every carbon involving sp3 hybridization, like this sp3 hybridization, means if one who involve in sp3 hybridization, that can make 4 hybrid orbitals. So here sp3 na, so means how many hybrid orbitals we will get? 4 hybrid orbitals, guys. Simply you should understand, if sp3 hybridization is there, 4 hybrid orbitals are formed. If sp2 hybridization is there, 3 hybrid orbitals are there. If sp hybridization is there, there are 2 hybrid orbitals. You should understand first that one. After that, after finding that hybridization, then if you sum the all hybrid orbitals, we can get total hybrid orbitals present in that molecule, guys. If you take an example, CH2 double bond CH bond C triple bond CH, if you take, there CH2 is there, not starting. At starting there is CH2 na, there it is with double bond na, means sp2 hybridization. sp2 hybridization means 3 hybrid orbitals. There it is also sp2 na, means 3 hybrid orbitals. There it is triple bond na, so means sp hybridization, so means 2 hybrid orbitals. Here also sp hybridization, so here also 2 hybrid orbitals. Total 3 plus 3 plus 2 plus 2, means there are 10 hybrid orbitals present in that molecule, guys. Like that we can calculate number of hybrid orbitals, guys. Then I want to move how to find pure orbitals in a given organic molecule. So number of pure orbitals in a given molecule. If someone involved in sp3 hybridization, it have no any pure orbital, no any pure orbital, guys, because carbon contains only one s orbital and 3 p orbitals in its outermost shell. So if those 4 orbitals are involved in hybridization, means it have no any pure orbital, guys. Then if it involve in sp2 hybridization, there is a remaining one p orbital na, so that remaining one p orbital is a pure orbital, one pure orbital. So if one who involve in sp hybridization, 2 p orbitals are considered as pure orbitals. I hope you understand. So if there is a hydrogen atom in the given organic molecule, hydrogen contain only one s orbital na, that one is not involved in hybridization, that involved in overlapping only, means that one is also considered as a pure orbital. So number of hydrogens are there in the given molecule, you should consider those are also pure orbitals. If sp3 hybridization is there, there is no pure orbital at the carbon atom. If sp2 is there, there is a one pure orbital. If sp is there, 2 pure orbitals are there. If hydrogen is there, then that count number of pure orbitals are present in that given molecule. So now I want to calculate pure orbital by taking one example. If you take this molecule, here double bond is there, means here double bond is there, means sp2 hybridization. Here double bond means sp2 hybridization. Here double bond, sorry, here there is only single bond na, means sp3 hybridization. Here double bond is there, sp2 hybridization. Here double bond is there, sp2 hybridization. Now here single bond, sp3 hybridization. Means if you take this sp2 hybrid orbital, there is a one pure orbital. Here sp2 means one pure orbital. Here sp3 means 0 pure orbitals are there. Now if you take here sp2 hybridization means one pure orbital, sp2 means one pure orbital. So sp3 means 0 pure orbital. So like this we can calculate number of pure orbitals and hybrid orbitals in the given molecule, guys. Now for example, if you take this molecule, now at starting there is a triple bond, means it is sp hybridization. Now there is a triple bond for this carbon also, sp hybridization. Now there is a double bond for this carbon means sp2 hybridization. At final there is a double bond again sp2 hybridization, means sp means two pure orbitals, sp means two pure orbitals, sp2 means one pure orbital, sp2 means one pure orbital. Total these pure orbitals are present. Now here hydrogen also there na. So those hydrogens, how many number of hydrogens are there? That many pure orbitals are present in that molecule. So here 1, 2, here 2, total 4 hydrogens are there na. So means 4 pure orbitals are there. Total here 2 plus 2 4, 4 plus 2 6, 6 plus 4 10. Total 10 pure orbitals are there. Are you understand, guys? Now the topic is ratio of hybrid orbitals and pure orbitals. Ratio of hybrid orbitals and pure orbitals. So have to take first example, CH2 double bond CH2. Here it is sp2 hybridization. Here it is also sp2 hybridization, because there is a double bond between them now. So sp2. Total sp2 means 3 hybrid orbitals. sp2 means 3 hybrid orbitals. 3 plus 3, 6 hybrid orbitals are there. Hybrid orbitals are there. Now if you observe that sp2 means there are 1 p pure orbital. So here sp2 means 1 pure orbital. Now total 2 hydrogens here, 2 hydrogens here. Total 4 hydrogens are there na. So means 1 plus 1 2 plus 4 6 pure orbitals are present. Now the ratio is 6:6. That is nothing but 1:1, guys. That is nothing but 1:1. Example number 2, CH3 bond CH3 have to take. Now CH3 means there is a single bond only na, means it is sp3. Now here this one is also sp3. So sp3 means 4 hybrid orbitals. Here also 4 hybrid orbitals. Total 4 plus 4, 8 hybrid orbitals are there. Now if you take pure orbitals, if sp3 means carbon have no pure orbital, but there are 3 hydrogens na. For hydrogen 3 pure orbitals. Here also 3 hydrogens na. For hydrogen 3 pure orbitals. Total 6 are there. Means if you take that 8:6. 8:6. That is nothing but 4:3. 4:3 is the ratio of hybrid orbitals and pure orbitals in that ethane molecule, guys. If you consider this example, CH triple bond CH. Now there is sp hybridization. Here also sp hybridization, means 2 hybrid orbitals here, 2 hybrid orbitals here, 2 hybrid orbitals here. Total 4 hybrid orbitals present in that molecule. If you calculate pure orbital, one who involve in sp hybridization, that means 2 pure orbitals are there. Here also 2 pure orbitals are there. Total 4 are there. Now there are 2 hydrogens in that molecule na, means 2. Total 6. That means 4:6. That equal to nothing but 2:3, guys. That is the ratio of hybrid orbitals and pure orbitals in that molecule. Now move to another example. Here CH2 double bond is there na, sp2, there sp2, there sp2, there sp2. Now 3 hybrid orbitals, 3 hybrid orbitals, 3 hybrid orbitals, 3 hybrid orbitals. Total 12 hybrid orbitals are there. sp2 means 1 pure orbital, 1 pure orbital, 1 pure orbital, 1 pure orbital, 4. Now hydrogens here 2, here 1 3, here 1 4, here 2. Total 6 hydrogens are there. That equal to 10 pure orbitals are there. Now 12 hybrid orbitals, 10 pure orbitals. Simply we can write that one as 6:5 is the hybrid orbital and pure orbital ratio in that 1, 3 butadiene molecule, guys. Now move to another one. Now if you consider this molecule, now first of all you should draw the structure of this molecule. There are two carbons now. At the side of this carbon there is a bracket. Within that bracket groups are there, CH3 groups are there, means these CH3 groups are attached to that carbon. Here these three CH3 groups are attached to that carbon. Now we can draw that structure, C bond C, then this carbon is pair with three CH3 groups now. So CH3 here, CH3 here, now CH3 here, there this carbon is also CH3, CH3, there downside also CH3. If you observe closely this molecule, all are with only single bonds now. All are with only single bonds. Means all are involved in sp3 hybridization only. Means total 1, 2, 3, 4, 5, 6, 7, 8 carbons are there. So sp3 means 4 hybrid orbitals now. So they multiply with 8, then 32 hybrid orbitals are present in that molecule, guys. Now if you count pure orbitals, there are no sp2 carbons, there are no sp carbons, means it have no pure orbital with respect to the carbon. Now hydrogens are there now. Here 3, 3, 3, 9, here 3, 3, 3, 9, 9 plus 9, 18 are there, means 32 is to 18. That is the ratio, means we will get 16 is to 9 is the hybrid orbitals and pure orbital ratio in that given molecule. Now move to another example. If you take simply benzene formula C6H6. Here every carbon involved in sp2 hybridization, because every carbon is connected with a double bond. That's why sp2 hybridization. So 6 carbons are there. sp2 means 3 hybrid orbitals, 6 3s are 18 hybrid orbitals are there. Now move to pure orbital. Each sp2 hybrid orbital can contribute one pure orbital. So 1 into 6, 6 pure orbitals, and hydrogens also 6 na. So plus 6, that equal to 12 pure orbitals are present in that molecule. Means 18 is to 12, that equal to nothing but 3 is to 2. So 6 3 is 6 2 is 3 is to 2. That is the hybrid orbitals and pure orbital ratio in benzene, guys. Now after completion of concept, I want to give shortcut to find pure orbitals. I told you how to find hybrid orbitals easily, but pure orbitals, look here, pure orbitals, number of pure orbitals equal to number of atoms other than carbon plus 2 into pi bonds. 2 into pi bonds. This is the simple formula to calculate number of pure orbitals, guys. For example, if you take CH2 double bond CH bond CH3. If you take like this molecule, their first one is sp2, middle one is also sp2 because it bear with a double bond, last one is sp3, only single bonds are there. Total 3 plus 3 plus 4, total 10 hybrid orbitals are there. Now if you calculate pure orbitals, move to that formula. So number of atoms other than carbon. Here other than carbon means only hydrogens are there. Here 2, 3, 3 plus 3, 6 plus 2 into pi bonds. Here there is only one pi bond. 2 into 1 means 2. Total 8 hybrid orbitals are there. Then 10 is to 8. Nothing but 5 is to 4. That is the way to find number of hybrid orbitals and pure orbitals for given organic molecule. I hope you understand the topic, guys. If you learned something from my video, have to like this video and subscribe my channel for more videos, guys. See you in next class, guys.